in class, we looked at a new topic called differentiation. And differentiation is just about the rate at which things change. So if we all had a glass of water for a class, would we all be drinking the water at the same rate? No. So we'd all have different rates at which the volume of the water in the glass is changing. My dad's a farmer, and he might care about the rate at which a cow is losing weight if he thought she was sick. As I get older, I get more wrinkles. So the rate at which I'm getting older at is different. It's different for everyone. Everyone, is aging at a different rate. So we put it usually a numerical. We put a numerical value on the rate at which something is changing. So if we talk about distance, if we all hopped on a bike and we went to Newbridge, would we all arrive at the same time? No, we wouldn't. And if you want at any stage, pause the video and have a think about this for yourself. But what is changing? Why are we not arriving at the same time? Why doesn't the distance change at the same rate? Now, as I said, pause the video if you want to and have a think about it. It should make logical sense why we're not all arriving at the same time, why the distance hasn't changed at the same rate for all of us. And that's because of our speed. We're probably all going at different speeds. So if we use the idea of the rate at which distance is changing, it's dependent on our speed. So if we get a function, let's say the function is x cubed. And if we apply a rule to it, so I'll talk about the rule in a few minutes, but if we apply the rule, the differentiation rule, or the rate of change rule, we will get a formula for speed. So if this was the formula for distance, and we apply this new rule, which I'm about to show you down here, then you would get a formula for speed. What about if we were looking at the speed at which a car was going? If we all sat into a car, would we all be travelling at the same speed? No. Again, pause the video if you want at any stage to have a think about this. What's the rate at which the speed is changing? So if you were sitting in a car and we weren't all going at the same speed, why is that? Are some of us braking? Are some of us accelerating? So the rate at which the speed is changing depends on how much we're accelerating. So if you happen to have a function for speed, you would apply this rule, this new rule that I'm going to show you in a few minutes, and you would have a formula for acceleration, because acceleration is the rate at which the speed changes. Hopefully you kind of have an idea of what I'm talking about there with rate of change. Let's have a look at the rule. So if you had the function y equals x cubed, this new rule, which you've never used before because we've never really talked about the rate at which something is changing instantaneously. So the rule for differentiation, or the rule for the rate of change, is you bring the power in front and you subtract 1 from that original power. So the 3 goes in front and you subtract 1 from this original power. So it was a 3, now it's a 2. If this was your function for distance, you're now, after applying this rule here, you now have the function for speed, because speed and distance are linked by the fact that we're not all arriving, the distance isn't changing at the same rate for everyone because we're all going at different speeds. So the rate at which the distance is changing is the speed. If we had another function, so let's say new question, and our function was y equals 3x squared. Our formula says, so the rule for differentiation is you bring your power in front, so that would be 2 in front of the 3, so 2 times 3, and you'll subtract 1 from that original power. So 2 times 3 is 6, and I subtract 1 from the original power. 2 minus a 1 is a 1. So you could write that as 6x to the power 1, or just a 6x. If this was the formula for distance, the original function 3x squared, then now here's your new formula for speed. If this was your formula for speed, this would be your formula for acceleration.